Good morning. Today in this session I am going to explain you some problems based on dot product and cross product of factors. Now let us start with the problems based on dot product of vectors. So look into this first problem carefully. Two vectors p bar and q bar are given. Find the angle between the two vectors. From the definition of dot product of two vectors is defined as the product of the magnitudes of the two vectors and cosine of the angle between them. So from that, if angle between two vectors is asked, the formula will be cos theta is equal to p bar dot q bar by modulus of p modulus of q, right? Now, modulus of p means the magnitude of p, magnitude of q. Now, look here. Let us write those two vectors. P bar is given as 2i plus 3j minus 4k. 2i plus 3j minus 4k. And q bar is given as 5i plus 2j plus 4k. See here, cos theta is equal to, from this formula, p bar dot q bar, 2 5s are 10, 3 2s are 6 minus 16. So if you just look at it, you need not work hard for the denominator because numerator is already 0. So 0 by something is always 0. So cos theta is 0. Cos theta is 0 implies theta is equal to 90 degrees. So the two vectors are mutually perpendicular. So in case of dot product of two vectors, we already know that when two vectors are mutually perpendicular, from this expression dot product of two vectors is 0. So here in this problem, angle between the two vectors is found using the formula p bar dot q bar by modulus of p modulus of q, and as their dot product is 0, angle between them is found to be 90 degrees. Let us go to the next problem. Look here. A force moves a particle from R1 to R2. Calculate the work done. R1 bar, that is 2i plus 7j plus 4k, is the initial position vector of a particle. On applying a force F, its final position vector is 5i plus 2j plus 8k. So R2 is 5i plus 2j plus 8k. Now the displacement vector is given by S bar is equal to final position vector minus initial position vector, that is 5 minus 2, that is 3, I bar, 2 minus 7, 2 minus 7 is minus 5, j bar, 8 minus 4 plus 4, k bar. So the displacement vector is 5 minus 2, 3i bar, 2 minus 7 minus 5j bar, 8 minus 4, 4k bar. And the particle moves from the point R1 to the point R2 by applying a force. F bar is equal to 5i minus 3j plus 2k. What is asked in the problem? Calculate the work done. So we know from the definition, work is the scalar product of force and displacement. So we need to just find out the scalar product of these two vectors. Look here. So work done is equal to, we are finding out scalar product. As I dot I is 1, it is 3 into 5, 15, minus 5 into minus 3, plus 15, plus 4 into plus 2, it is plus 8, that is 38 units is the work. So correct option for that formula is the first option. Okay. Now let's go to the next problem. A vector perpendicular to the given vector having magnitude of 3 root 5 Newton. So, let us take the given vector as A bar, that is equal to I bar plus 2j bar. You are asked to find a vector perpendicular to the given vector with magnitude 3 root 5. There are so many probabilities for a vector perpendicular to this. So, here it is mentioned that that vector has to be perpendicular to the given vector and its magnitude must be 3 root 5 units. So, here first let us check from the options. For this vector, what is the magnitude? For the first option, magnitude of the vector is root of 3 square plus 6 square. If you take that 3 square as common factor outside, 1 square plus 2 square. So, 3 root 5. For the first option, magnitude is 3 root 5. For the second option also, it is root of 6 square plus 3 square. So, it is also 3 root 5. Magnitude is 3 root 5. And for these two vectors, very obviously, magnitude is not 3 root 5. Look, so for the third option, root of 4 square plus 2 square. So, this is 2, if you take it as a common factor, 2 root 5, and for that it is something else. Okay. So, very obviously third option and fourth option are not the answers. It can be the first option or second option. So, because the two vectors are having the same magnitude, that is 3 root 5. Now, the next check is our given vector A bar must be perpendicular to this. So, when two vectors are perpendicular, immediately we say the dot product of the two vectors is equal to 0. So, A bar is given as I plus 2j. If you say look at the first option, very obviously as those two are positives, these two are positives, that cannot be the vector perpendicular to this one because dot product cannot be 0. So, let us try with the second option. Let us take this as B bar, that is equal to 6i minus 3j. 6i minus 3j. So, if you take the dot product of these two vectors, it is 1 into 6, 2 into minus 3 is minus 6, that is equal to 0. So, for 6i and 3j, I plus 2j are mutually perpendicular as their dot product is equal to 0. That condition is satisfied. And the next condition is for this second 6i minus 3j, magnitude is 3 root 5. So, the correct option is the second option. As the two vectors are perpendicular, their dot product must be 0. And the magnitude of the vector must be equal to 3 root 5. So, those two conditions are satisfied for second option. So, for that question, second option is the right choice. Now, let us go to the next problem. If the vectors P and Q are perpendicular to each other, then the positive value of A. So, here by this time, if two vectors are said to be perpendicular, immediately we take their dot product as equal to 0. So, here as the two vectors P bar is AI plus AJ plus 3K and Q bar is equal to AI minus 2J minus K are mutually perpendicular, P bar dot Q bar is equal to 0 implies A into A square, A into minus 2, minus 2A, 3 into minus 1, minus 3, 0. This is a quadratic equation. Very obviously, the factors for 3 are 3 and 1. So, this is A minus 3, A plus 1 is equal to 0. So, A is equal to 3 or A is equal to minus 1. what is asked in the question? What is the positive value of A? So, positive value of A is equal to 3. So, the correct option for that is 3. Suppose if you are asked to find out the negative value of A, then it will be 1. So, in the question it is asked, you are asked to find out the positive value of A, that is equal to 3. Okay? And now, next one. Look here, 2 vectors are given. You are asked to find out the component of one vector along the other vector. Look here, suppose this is a vector A bar, this is a vector B bar, and this is angle theta. If you drop a perpendicular, this becomes component of A bar along B bar. So, if you take this as AX is equal to A cos theta or modulus of A cos theta, and cos theta is given by A bar dot B bar by modulus of A modulus of B. This and this gets cancelled. This implies component of A bar along B bar is equal to A dot B by modulus of B. Similarly, if component of B bar along A bar is asked, see here, component of B bar along A bar is asked. So, on the same concept, component of B bar along A bar is equal to A bar dot B bar by modulus of A. That's it. Okay. So, here look, A bar is given as 2i plus 3j and B bar is given as 2j plus 3k. 2i plus 3j, 2j plus 3k. So, we have to do it very carefully. See here, component of B bar along A bar will be equal to A dot B. This is I, this is j, I dot j is 0, I dot k is 0, j dot k is 0, but j dot j is 1. So, 3 into 2, that is 6. 3 2s are 6. So, 6 by modulus of A. Modulus of A is root of 2 square plus 3 square, that is 6 by 2 square is 4, 3 square is 9, a root 13. So, correct option is 4th option here. Component of B bar along A bar is A bar dot B bar by modulus of A. Okay. Now, next one. Look here, a similar question. So, just for practice we can do that. Component of A bar along B bar. See, component of A bar along B bar is A dot B by modulus of B is a root 3 times component of B bar along A bar. Component of B bar along A bar is A dot B by modulus of A along A bar. So, you get modulus of A, along B bar you get modulus of B in the denominator. So, from that A dot B gets cancelled. What is asked in the problem? A is to B. So, just on cross multiplying, A by B is equal to root 3 or A is to B is root 3 is to 1. Okay? Now, let us go to the next question. If theta is the angle between unit vectors A bar and B bar, then you need to find out the answer. So, unit vectors A bar and B bar, meaning modulus of A is equal to 1, modulus of B is equal to 1, because A bar and B bar are given as unit vectors. Now, you are asked to find this value 1 minus A bar dot B bar by 1 plus A bar dot B bar. 1 minus A bar dot B bar is AB cos theta by 1 plus A dot B is AB cos theta. So, as A, B are unit vectors, AB becomes equal to 1. So, this is equal to 1 minus cos theta by 1 plus cos theta. 1 minus cos theta is 2 sin square theta by 2. 1 plus cos theta is 2 cos square theta by 2. So, this and this gets cancelled. Sin square theta by 2 by cos square theta by 2 is equal to tan square theta by 2. That is the answer. Okay. So, answer is first option is the right answer. Just if you look at it as AB or unit vectors, this becomes 1 minus cos theta, 1 plus cos theta. 1 minus cos theta is 2 sin square theta by 2 by 2 cos square theta by 2. Sin square by cos square is tan square theta by 2 is the answer. Now, let us go to the next one. Same model we have already done. A vector perpendicular to the given vector 3I bar plus 5j bar. Actually, if this is the problem, we have to verify with all the options. If you need to identify the vector which is perpendicular to the given vector, you have to see whether their dot product is 0 or not. The two vectors are perpendicular always implies that their dot product is 0. See here, just by looking at the options, can you answer? It's very simple. The given vector, say A bar, is in xy plane because it has only component along x axis and y axis. It has no component along z axis. That means that vector lies in xy plane. So, very obviously z axis is perpendicular to xy plane. In this case, if you look at this option, the vector given there is 5k bar. So, that vector is along z axis with a magnitude 5. So, as the given vector A bar is in xy plane, as this vector is along z axis, that is perpendicular to the given vector. Okay? Now, the next question. So, here look at this option. Find the work done by the force. Already we have done a similar model. So, force is given as 2I minus j plus 5k. It displaces the body from a point. This is the initial point. So, initial position vector will be 3I plus 4j minus 6k. Displaces the body to this point. So, the final position vector is 7I plus 2j plus 5k. Then the displacement vector is R2 bar minus R1 bar. 7 minus 3, 4I, 2 minus 4, minus 2j, 5 minus of minus 6, plus 6k. 5 minus of minus 6, 11. Kada? This becomes plus 6, 5 plus 6 is 11k. So, I am just verifying that. So, 7 minus 3, it is 4, 2 minus 4, minus 2, 5 minus of minus 6, 11. So, work done is the dot product of force and displacement. See here, work done is equal to F dot S, 2 into 4, 8, minus 1 into minus 2, plus 2, plus 5 into plus 11, 55. So, answer is 65 units. So, the first option is correct for that problem. Okay? So, that is about work done when a force displaces a body from one point to the other point. Again, look at this problem. P bar and Q bar are two unit vectors angle between them is 60 degrees, then find 1 plus P dot Q is PQ cos theta by 1 minus P dot Q is PQ cos theta. Okay. So, as the vectors are unit vectors, PQ becomes equal to 1. So, 1 plus cos theta by 1 minus cos theta. What is 1 plus cos theta? 2 cos square theta by 2, and 1 minus cos theta is 2 sin square theta by 2. This is 2 sin square theta by 2. 2 and 2 gets cancelled. So, this is cot square theta by 2. Cos square by sin square. So, theta theta is given as 60 degrees. So, this is cot square 60 by 2, that is 30 degrees. So, cot square 30. Cot 30 is root 3, cot square 30 is 3. So, answer is 3 for that problem. Right? Now, let us go to the next problem, that is, look here. You are supposed to find out the angular momentum. Actually, here all the next problems are based on cross product of two vectors. So, we should know the formula for cross product. So, here A bar is equal to AX I bar plus AY J bar plus AZ K bar, and B bar is equal to BXI plus BYJ plus BZK. Then A bar cross B bar is given by I bar into AYBZ minus AZ BY minus J bar into AXBZ minus AZBX plus K bar into AZBX minus AXBZ. This we must know to do the problems based on cross product of two vectors. See here, mass of the particle is given as 0.2 kg. Moving with linear velocity 4I plus j minus k. No, this is not the velocity, this is the radius vector given. Okay, a particle of mass 0.2 kg moving with a velocity I minus j plus 2k. Radius vector is 4I plus j minus k. Find the angular momentum of the particle. So, first of all, we should know the expression for angular momentum or relation between angular momentum and linear momentum. L bar is the angular momentum, R bar is the radius vector, P bar is the linear momentum, then L bar is equal to R bar cross P bar, right. So, this, look here. So, and we know P is equal to mv, so P bar is equal to mv bar. So, first of all, let us write here R bar is equal to 4I plus j minus k. P bar is equal to m into v bar, 0.2 I bar, right, 0.2 minus j bar, I bar minus j bar, 0.2 into j. So, minus 0.2 j bar, 0.2 into 2k bar plus 0.4 k bar. So, we just multiplied this velocity with mass. So, 0.2I minus 0.2j plus 0.4k. Now, we need to find out the cross product of these two vectors. So, R bar cross P bar is equal to I bar into 1 into 0.4 minus 1 into minus 0.2. So, plus minus of minus, but again AY BZ minus AZ BY, minus AZ BY. So, 3 negatives. So, 0.4 minus 0.2 minus J bar into 4 into 0.4, 1.6 minus 0.2, okay, plus K bar into 4 into minus 0.2, that is minus 0.8 minus 0.2, minus 0.2. So, from this becomes 4 minus 2 is 0.2. So, this is 0.2 I bar, 1.6 minus 0.2 is 1.4, 1.4 J bar, 0.8 plus 0.2 is 1. So, minus K bar. This is vector form. So, to find out the magnitude, square root of 0.2 square, 1.4 square plus 1 square. See, I have already done the calculation, you will be getting it as 4.28, does not matter. So, square root of 0.2 square plus 1.4 square plus 1 square, we need to find it out. So, anyway, see, look here, it is 0.04, 1.4 square is 1.96 plus 1. So, it is square root of 2.96, it is root 3 something, okay. So, 0.04, this becomes 2 plus 1 root 3. So, there is a mistake, we can just check it over quickly, okay. So, there might be an error in this. So, look here, mass is 0.2 kg, I am checking the data basically, right. So, mass is 0.2 kg and linear velocity is I minus j plus 2k and radius vector is 4i plus j minus k. So, angular linear momentum mv, that is 0.2 I minus 0.2 j plus 0.4 k. R bar is 4i plus j minus k. So, look here, I bar into, I am doing it again, I bar into 0.4 minus 0.2 minus j bar into 1.6 plus 0.2 minus of plus 0.2 plus k bar into minus 0.8 minus 0.2. So, here we made a mistake in the previous problem. So, here I into 0.2 minus j into 1.8 plus k into 1. So, this is square root of 0.2 square 0.4, 8 18s are 34. So, 324. So, 3.24 plus 1. So, this is 4.28 under square root. So, this is the right option, right. So, here just angular momentum is equal to r bar cross p bar, where p bar is equal to mv bar, that is it. And you have to be careful in finding out the cross product of the two vectors, okay. Now, let us see the next problem. Look here, the magnitude of scalar and vector product of two vectors respectively. What is the angle between the two vectors? Magnitude of scalar product of two vectors is AB cos theta. Vector product of two vectors is AB sin theta. What is given here? Magnitude of scalar and vector product of vectors are 48 root 3 and 144 respectively. So, look here, scalar product is given as 48 root 3 and vector product AB sin theta is given as 144. If you divide this, that is sin theta by cos theta, AB gets cancelled, tan theta, that is equal to, if you take this as equation 1, this as equation 2, 2 by 1 implies AB gets cancelled, sin theta by cos theta is tan theta, that is equal to 144 by 48 root 3. 3 times, this is root 3 times. Tan theta is root 3, theta is equal to 60 degrees. So, angle between the two given vectors is 60 degrees, right. Now, let us see the next problem. See here, what is the condition for the vectors 2i plus 3j minus 4k and this to be parallel? See here, actually A bar cross B bar magnitude is AB sin theta. If the angle, if they are parallel, angle between them is 0, A bar cross B bar must be equal to 0. A cross B is equal to 0. Actually, if you prove that this is possible only when A bar is an integral multiple of B bar. That implies if A bar is equal to AXI plus AYJ plus AZK, B bar is BXI plus BYJ plus BZK, then AX by BX is equal to AY by BY is equal to AZ by BZ must be a constant factor K or N, whatever, must be a constant. If this constant is positive, the angle between them is 0. If that constant is negative, angle between them is 180, then the two vectors are said to be anti-parallel. Once again, coming back, if one vector is an integral multiple of another vector, then both of them are, angle between them is 0 if the integer is positive. If the integral multiple low, if the integer is negative, angle between them will be equal to 180 degrees. Okay. So, here it is given that, see, A bar is equal to 2i plus 3j minus 4k and B bar is given as 3i minus aj plus bk. Both of them are parallel, meaning ax by bx must be ay by by must be equal to az by bz. Ax by bx is equal to 2 by 3. It must be ay by by. Just from this expression on cross multiplication, minus 2a is equal to 9. So, a is equal to minus 9 by 2. That is the value of a. So, this is the right option. Let us check with B also. Look here, AZ, AX by BX is 2 by 3. AZ by BZ is minus 4 by B. So, this gets cancelled 2 times. B is equal to minus 2 into 3, that is minus 6. So, the first option, A is equal to minus 9 by 2 and B is equal to minus 6 is the correct answer if those two vectors are parallel vectors. Okay? Now, let us go to the next problem. Look here. In this problem, it is mentioned that A bar, B bar are the magnitudes of the two vectors. If A cross B is 0, A bar cross B bar is equal to 0 implies AB sin theta is equal to 0 implies sin theta is equal to 0 or theta is equal to 0 degrees. Simply we can say cross product is 0 implies angle between them is 0. What is the dot product? What is A dot B? So, we know A bar dot B bar is AB cos theta. So, AB cos 0, because from the first statement we could find out the angle between the vectors as 0. So, AB cos 0 is, this is AB cos 0. What is cos 0? 1. So, this is just equal to AB. That is the correct option for that problem. Okay? So, if cross product is 0, angle between them is 0, then the dot product will be maximum. Okay? That is AB. Now, let us go to the next problem. Look here. Here, it is given like this. A bar, B bar are given, then vector perpendicular to both A bar and B bar has magnitude k times that of this vector. Find. See here, A bar, B bar are given vectors. If you find the cross product of two vectors is perpendicular to both of them. So, in this problem he mentioned that A bar, B bar, then vector perpendicular to both A bar, B bar means we need to find out the cross product. First, let us find out the cross product carefully. A bar is given as 2i plus 3j plus 6k, and B bar is given as 3i minus 6j plus 2k. So, A bar is given as 2i plus 3j plus 6k, B bar is given as 3i minus 6j plus 2k. Okay, A bar cross B bar is equal to I bar into 3 2s are 6, minus of minus plus 36, minus J bar into 2 2s are 4, minus 3 6 are 18, plus K bar into 2 into minus 6, minus 12, 3 3s are 9, minus 9. So, I am just verifying it once again. I bar into 6 plus 36, J bar into 4 minus 18, K bar into minus 12 minus 9. So, this becomes 42 I bar, 4 minus 18 is 14, minus of minus plus 14 J bar minus 21 K bar. So, here now read the problem once again. A bar, B bar are given, then the vector perpendicular to both A bar and B bar has magnitude k times that vector. So, let us find out the magnitude of the vector which is perpendicular to both A bar and B bar. That is, we need to find out this magnitude. If you look at this, it becomes a root of 42 square plus 14 square plus 21 square. See, very obviously 7 is common here. This is 6 square plus 14 square, 7 if you take it as common factor outside, 2 square plus 3 square. Now, I got a brilliant idea. Look, you can do the calculation very easily. Just if you look at this, what is given in the problem? The magnitude of the vector which is perpendicular to both A bar and B bar has magnitude k times the magnitude of this vector. Look here, its magnitude is k times root of 6 square plus 2 square plus 3 square. If you observe, this 6 square plus 2 square plus 3 square gets cancelled, it is k is equal to 7. So, the correct answer for that problem is k is equal to 7. Okay? So, here the point is vector perpendicular to both A bar and B bar is nothing but just their cross product. Okay? And the magnitude of that vector which is perpendicular to both A bar and B bar is k times the magnitude of this given vector. So, you just asked to find the value of k. Now, look into the last problem based on this topic. Okay? Vertices of a triangle are given, then area of the triangle. look here. If you see the applications of cross product, we have learned two things. Area of a parallelogram is A bar cross B bar if A bar B bar are the adjacent sides of a parallelogram. Area of a parallelogram with A bar B bar as the diagonals is half of A bar cross B bar. Similarly, area of a triangle is equal to half of A bar cross B bar if A bar B bar are the adjacent sides of a triangle. Right? Here, look here very carefully. In this problem, you are given that vertices of a triangle. Let us take this point as P, this point as Q, this point as R. Right? Vertices, this is given as 1, 3, 2, I bar plus 3j bar plus 2k bar, and this is given as 2i. Okay, let me write this in the vector form, 2i minus j plus k, and this is given as minus i plus 2j plus 3k, minus i plus 2j plus 3k. This is given as I plus 3j plus 2k. Right? Now, this is one side, this is one side, this is another side. Then, if you take this as A bar, this as B bar, half A bar cross B bar gives you area of the triangle. So, A bar is equal to, look here, A bar is equal to R bar minus P bar, R bar minus P bar, that is equal to minus of minus 1 minus 1 minus 2i, 2 minus 3 minus j, 3 minus 2 plus k. So, that is A bar. Similarly, find out B bar. B bar is equal to Q bar minus P bar. 2 minus 1. B bar is equal to 2 minus 1. It is I bar. Minus 1 minus 3 minus 4j bar. 1 minus 2 minus k bar. So, let me verify this once again. So, we have taken this as P, right, this as Q and this as R. So, A bar is R minus P, R minus P, minus 1 minus 2. A bar is minus 1 minus 1, this is minus 2, this is 2 minus 3 minus 1, 3 minus 2, it is 1, right, and B bar is equal to Q minus P, that is, this is Q and that is P, 2 minus 1, 1, minus 1 minus 3 minus 4, 1 minus 2 minus k bar. Now, we need to find out the cross product of A bar cross B bar. So, a cross product, I am writing it here, I bar into my 1 into 1, minus 1 into minus 1, minus of minus becomes plus, minus j bar into, it is 2, minus 1, plus k bar into 2 4s are 8, minus of minus becomes plus 1, right. So, A bar cross B bar is equal to 5i plus j plus 9k. Okay. So, if you find out the magnitude, this is root of 25 plus 1 plus 81, this is square root of 107. Okay, area is half the if area is expressed, if the magnitude of the area is given, you have to simply take the modulus. So, this is half of modulus of A cross B is 107. So, the answer is root 107 by 2. The first option is correct for that problem. So, here there are two very important things. First, we should know how to find out the cross product. Keep it aside. That is the fundamental. In case of a triangle, area is half of A bar cross B bar, where A bar and B bar are the adjacent sides. In this problem, vertices are given. So, you have to find out A bar and B bar carefully. So, A bar R minus P, B bar Q minus P. When once A bar, B bar are properly found, it is very simple. Half A bar cross B bar gives you the area of the triangle. Okay? So, there are certain examples for cross product of two vectors. Okay? In the next class, I am going to continue with resultant velocity, change in velocity, relative velocity and so on. Thank you and bye-bye.